Hello everyone, I'm Ruchika Gupta. I'm working as a tech lead with Security Working Group in Linaro. I have Etienne with me. Etienne?
Yeah, hello Ruchika. Hello everybody. Thanks for watching this video. I am Etienne Carrière. I work for ST Microelectronics and work also with Linaro as an assignee. This talk is about PKCS11 in OPTI. It's a story that started a few years ago, like 3 or 4 years ago, and since last year is something really effective in the OPTI project. So we will present you first, well, what is the PKCS specification and what is the OPTI and how OPTI can leverage PKCS or PKCS can leverage OPTI. Afterward, we'll make a short status on the latest OPTI tags that was released. And we'll go through a bit of details in the client library and the trusted application architecture. And we'll show you the next steps afterwards. Ruchika?
Yeah. So now let's begin with an overview of the PKCS11 specification. So what is PKCS11? It is a platform-independent API that can be used to manage and use the cryptographic security hardware. Now, what is this hardware? This can be smart card, USB keys, and even remote HSMs. So what PKCS11 does is it abstracts the specific detail of the underlying communication between the application and the cryptographic hardware. Now, this communication can be over a hardware bus, maybe I2C, SPI, or even over a network with a remote firmware, which is running on a crypto device. Now, what does the client application do? It calls the PKCS11 API, which is either provided by a vendor-specific or a common crypto key library, and which then calls into a kernel driver, which communicates with this remote firmware. In this specification, these devices are usually referred to as tokens, and that is how we will be referring to them as we move forward in the presentation. The PKCS11 APIs allow the applications to manage the cryptographic objects on the token. So these objects can be keys, certificates, or data. And by management, the applications can create, modify, or destroy these objects. Then application can also call the crypto key APIs to use these objects for various crypto operations like maybe ciphering or authentications. With respect to user authentication, the token allows two types of user. One is security officer or a normal user. So the user can authenticate itself to the token either with a PIN or alternate means. So PKCS11 is no doubt a popular standard which is used by many HSMs. So before we move forward, Etienne will help introduce our audience to some packages which can interface with these PKCS11 APIs. Over to you, Etienne.
Yeah, thank you. Yes, PKCS11 API is already used in some well-known packages like OpenSSH. GNU TLS also has a PKCS interface. Python has a PKCS library. And there are also packages like OpenSSL, which does not provide a native PKCS11 engine, but there's an alternate package that proposes one, and that is used already by well-known distributions. And hopefully OPTI also will support PKCS11. Just remember that PKCS11 is a standard, it's well-known and well-used, but we must be very careful when implementing the features so that it's well implemented, and if there's some weaknesses in the specifications, it's addressed before there's a new release of the specification.
Right. And now as we kind of move in how this is implemented in OPTI, let's talk in brief about what OPTI is. I'm sure audience already knows about that, but just a brief overview. So OPTI is a trusted execution environment which is designed as a companion to the non-secure world Linux, running on Cortex-A CPUs using ARM Trust Zone. And let's talk in brief about the various OPTI components. So it includes, on the Linux side, a user space library, which exposes the global platform APIs which the client can use, and a TE driver for the communication. So the client apps talks to the corresponding trusted application which are there on the secure world side. And on the TA side, you have a user space library, which exposes various APIs like crypto APIs, object management APIs for the TAs to use. Now, you might be wondering, I mean, if we already have these crypto and the object management APIs available, then why do we need a generic PKCS11 API?
Global Platform's T specification does not provide cryptographic objects or operation available to the client application. It's only the internal trusted application libraries and APIs that allow such objects. And for a client to manipulate all those features from the OPTI, we need a clear API exposed to the client. So this is where the PKCS11 API can really fill the gap between clear objects and operations visible from the client and the way we can handle such objects in the secure world.
So basically, we are helping the users, I mean, not to kind of reinvent the key management APIs, perhaps, and use a ready-made available PKCS11 APIs. Now, let's move towards the design, how the design for the PKCS11 token and the crypto key library looks. So we've already talked about the two components of with the OPTI. So one is the client-side component and one is the trusted application side. So what we have is we have a libckTEC, that is the crypto key T library, which is equivalent to a crypto key library, which is available from OPTI client. And then we have a corresponding trusted application. So it's available in the OPTI OS, which acts as a remote enclave or a remote hardware token. And we also provide an X tests, which are there in the OPTI test. So libckTEC, in short, is a crypto library which exposes the PKCS11 APIs to the client application. It's hosted in OPTI client JIT, and it converts the crypto APIs to the global platform APIs in invoke commands. So, and what we have is we have a PKCS11 token, which is emulated by a TA in OPTI. So code is available in OPTIOS.JIT for that. So this is just a brief overview of the components which are there for the PKCS11 token.
Yes, and with this setup, well, it's a huge setup and a lot of features and things to be exposed to the client and things to be implemented in a trusted application. So it's no stories that started more than 3 years ago. It was presented like in 2019 at the Hong Kong Linaro Connect. And the project just matured a bit to get more features in. And we started thinking on how to review this piece of code, because it was a quite big amount of lines of code to be reviewed and fully maintained by the OPTI project. So last year, Linaro decided to put an effort on making a deep review of this code and bringing it to the upstream. And now we archived, we are pretty happy to say that we archived the main basics of a PKCS token. And now we can really start implementing cryptographic APIs and objects that will really serve in the real world. So what we archive today is a slot and token discovery and management, all the user session management and with the user authentication based on pins, and also an alternate authentication means based on Linux access control lists. We manage basic objects, being session or permanent objects, as well as key generations. We do a bit of ciphering. We do a bit of key derivation, currently only AES derivation by encryption. We do a bit of MAC computation, digest, random number generations. And as Rojika just told previously, we have a non-regression test suite that is available and to allow us that as we progress in the development and reviews, everything is still working as expected. So just give it a try. You can download the OPTI QEMU deliveries. Just make a run with the CFG PKCS11 TA equals yes, and run the QEMU emulation. And using the PKCS11 tool, for example, you will be able to see the slots and tokens that are provided by the PKCS11 TA. And now let's talk a bit about the client library internals.
Yeah. So now what's there in libckTEC? So for every CryptoKey API, which the library exposes, we have a corresponding PKCS11 TA command ID. And this command ID is then used by the trusted application. So what all does this libckTEC do? So it is a very thin wrapper layer and doesn't do much complex processing. All the complex processing is taken care by the TA. So what this library basically does is it serializes the arguments which are received in the CryptoKey API and sends it to the TA along with the TA command ID. For the serialization, there could be things such as session ID, object ID, attribute templates, mechanisms, or the data which needs to be processed. And the TA does its magic, and once it receives the output back, so it is also responsible for deserializing this data. And this can be, while deserializing, this could be the error or the success code, maybe the object IDs or object attributes in case of get attribute value. So just remember, this is a very thin wrapper layer. The main intention is to communicate with the TA, which is sitting on the OPTI side. And now further, CryptoKey APIs can be divided into various categories. As Etienne just mentioned, we have general purpose APIs, slot management, session management, key management, and even the crypto function APIs. So most of these APIs are already defined in the PKCS11 TA APIs. We have the list mentioned in the slide over here, and there are still a few missing ones. Contributions are always welcome. So please feel free to send in a patch to add any of these missing APIs. And now let's move towards the design of the TA. So as I mentioned, libckTEC is a thin wrapper. So now if you can explain in the design of the TA, the PKCS11 TA, which sits in the OPTIOS.
Oh, thank you, Ruchika. We don't have enough time to really dig into the PKCS11 TA design and implementation. So we just put some big important points here. So the TA supports client sessions. So the TA can implement several isolated tokens, each with its own secure storage and private objects. Session and object reference are all registered using lists in the TA, so that sessions are bound to clients and objects are bound to sessions or to the token itself. So we use a list to register all that and to handle all those objects. As far as the objects are lists of attributes. So in the PKCS11 TA, all these attributes are stored in a serialized byte stream, and it is the way it's handled in the TA, and it's also the way the object is stored in the secure storage when it's a persistent object. And so each time an object will be used or will be created for some processing, the object attributes will be checked against the user credentials, the token state, or the target processing expected. As Ruchika just said regarding the crypto operations, in the PKCS11 TA, we rely on the OPTI itself to do all the cryptographic part as well as the secure storage part. So the PKCS11 TA is based on the global platform internal core T API for all those management. I guess that's all we'll say on the TA implementation. The code is there, so feel free to have a look at it and comment if you want. Let's talk a bit about user authentication specifically. In the pristine PKCS11 specification, the standard way to log into the token for a user is to provide a PIN value. So this was handled from the very beginning in the PKCS11 OPTI project. And we had this nice contribution from Visa and Hero from Vesela OH that proposes a scheme where we can benefit from the Linux access control lists and the user and group IDs to allow specific applications to register and to authenticate into the token without needing a PIN that should be stored in the client non-secure world and may be exposed. So the all user authentication of the PKCS11 token would be based on the Linux access control list. And so the contribution from Visa Enro proposes all the implementation in the several non-secure and secure parts, and they also propose a configuration tool to help one defining the credentials for the security officer and user using either PIN or Linux ACL means.
Okay.
Now let's talk a bit about the testing part. Ruchika?
Yeah. So how do we test the PKCS11 APIs which we have added? So one thing which we do is we use the OPTI test suite, that is the X tests. So as we are adding new APIs, we add in tests over there. And with each test, we try to test both valid as well as the invalid cases for the APIs and some minimal crypto algorithm compliance. So in order to run these tests, you can use the X test with an option PKCS11, and you'll have the PKCS11 tests running. So apart from that, we are also exploring that if we can use some already available test suite. So PKCS11 is a well-known standard, but unfortunately, we didn't find any standard compliance suite which is available, which can be used to test these PKCS11 APIs and confirm to us whether we are actually compliant to the standard or not. So it looks like every HSM does their own testing. But we did find two of the test implementations, which may not be complete, but do help us enhance the compliance testing which we want to do. So one of these is the PKCS11 test. So this is a test suite which is using Google Test Framework. And we've given in details on how you can build it and use it for the testing. We are trying it in the Chemo environment. But please note that this is a work in progress. So you'll see that there are failures when you're trying this thing out. This may be due to the missing features in the implementation, which we are in the process of adding. And sometimes there is a variation in the type of error code which is returned. Like the specification is not very clear on whether we should be returning a template incomplete or a template inconsistent type of error. So that kind of mismatches are there. So we're looking at these failures and we'll fix them as we move along. So again, contributions are welcome for this. And another test suite which we are exploring is the unit test, which is available with the Soft HSM. So Soft HSM is a software-based implementation for an HSM which exposes PKCS11 APIs. It is widely used by people just for testing stuff out. And it also has a well-formed unit test suite, which can be built standalone and used with other crypto key libraries. So this is what we tried. We picked up this unit test from the Soft HSM and tried to compile it standalone and then use it with the crypto key library, which we expose using OPTI. And details are available at the link, which is over here. Again, a note, this is again a work in progress. You'll see many cases failing, but this will give you an idea of where we are with respect to the compliance. Then Etienne mentioned about various packages, standard packages which are available. So PKCS11 tool is one of the popular packages and which provides in command line utilities to use these APIs without getting into the details of APIs or the parameters, etc. We already have it added in the build root in the OPTI build environment. And on the slide, we've also added a few sample commands which can help you play around with the token, like get in the token, slot information, initialize the token, generate a key, list objects, etc. So please feel free to try it. Any feedback is welcome or any contribution is welcome for the same. So now this is about the testing and what are we going to do as next steps. So now that we have the basics in, like we have the basics of most of the session management, the cryptographic operation which are in, we are really looking forward to adding the ECDSA and the RSA support. And this would make release ready to be used for a remote token for platforms that support OPTI for real life use cases. So EC patches PR is already there in review, and thanks to VESA for that. And we're also looking at implementing the wrapping and the unwrapping APIs and add in more mechanisms for symmetric ciphers, MACs, or the key derivation functions. And as I mentioned about the test suites, we want to improve in the test results of PKCS11 tests and the soft HSM unit tests. So it's another thing which we want to accomplish. There are some improvements which can also be done from design perspective.
Yes, currently these are some areas that are quite raw in the implementation that could be refined. So in the next steps, maybe we can improve the data storage, maybe to split private objects from specific objects, or to make a better isolation of the tokens that are implemented by the TA when there are several tokens. Also, we should do some garbage collections of the secure storage content, because during the lifetime of the TA, there may be objects that are created, and while the device runs into some power failure, and some left content in the secure storage that must be cleaned. So it's something we should address, and also put some documentation in the OPTI generic documentation about what is supported in the PKCS11 TA. Well, thanks. Thank you everybody for watching this video, and we really want to make a warm thanks to everybody that contributed to this project, with all the contributions being code reviews, issues, comments, or whatever. So we put few of the names here that really participated, but it's not all of them. So thank you to all of them, and let's see this still progressing and reaching a really useful state. Thanks to all. And if you have questions, do not hesitate to use the chat. Bye.
Bye, everyone. Thanks for attending the session.